Hi, welcome children. Today I am going to explain about the Unit 9 of the Grade 10. Unit 9 of the Grade 10. The Unit 9 of the Grade 10 is Resultant force. Unit 9 of the Grade 10 is Resultant force. Under this topic, you will be able to learn about what is the resultant force and also resultant of the two force, resultant of two parallel force and resultant of two collinear force, resultant of two collinear force in same direction and opposite direction, and resultant in inclined flows. Right, okay, those things you will be able to after end of the lesson. Right, first we will go to learn about the resultant of several force, the resultant of several forces. Right, in previous lessons you have learned about what is the force, no? Right, in this lesson you will be able to learn about what is the resultant of several force. Right, now look at this picture. There is a car. This car is pulled by a single man. Right, this car is pulled by a two man. This car is pulled by a three man. Right, what is the on the which car exerted the large number of the force? One person pushing a car, two person pushing a car, three person pushing a car. Right, okay, so what is the resultant force? The resultant force mean the single force. The single force act on the object due to three forces. Now when we consider about this picture, right, resultant of this object means the single force. The single force exerted on the car due to these two persons. Now when we consider about the resultant of this picture, this car, the single force exerted on this car due to this person. Right, okay, now we could take under some idea about the resultant force. If not, you will be able to what is meant by resultant force by this. Right, now you can look at what is the resultant force. When more than one force is applied, when more than one force is applied, the single force that gives the same result, the single force that gives the same result as of all the contributing forces is known as resultant force. Resultant force of the individual contributing force, of the individual contributing force. Now think about again this diagram. Now when we consider about this diagram, now think about the single force exerted on this object is F. Right, this person provide a F1. F1. Next person provide F2. F2. This person provide F3. So what is the resultant? So what is the resultant? The resultant force mean the single force. The single force. The single force. If not F, resultant force mean F. The resultant force mean the single force that should be provided instead of these three force. If not, resultant force can be taken as addition of these three forces, F1 plus F2 plus F3. In that situation, resultant force can be taken like that. Right, now we have learnt about what is meant by resultant force, no? What is meant by resultant force? Right, again we will see what is the resultant force. When more than one object is applied, the single force that gives the same result as that of all the contributing forces is known as resultant force of the individual contributing forces. Individual contributing forces. Right, then we will go to our next topic. Resultant of two collinear forces. Resultant of two collinear forces. The collinear forces mean the force exerted on the same plane. The collinear forces mean, collinear means same place. So resultant of two collinear forces mean the forces exerted on the same plane. Same plane. It may be same direction or opposite direction. Right, firstly we will learn about resultant of two collinear forces acting along the same direction. Right, now look at this diagram. Right, this is the collinear force because these all the force are exerted on the same plane, and also all the person applied the force into the same direction. Right, now tell me how to take the resultant force in this situation. How to take the resultant force in this situation? The resultant force in this situation can be taken by addition of the each individual force. Right, now think about as example. Now think about there is a object like that. There is a object like that. This object is on this object exerted F1 force and also F2 force. It is similar to this diagram, no? Right. Then resultant force means the single force that should be supplied instead of these two force, no? Now think about if the resultant is F. If the resultant is F, how to take the resultant? Resultant can be taken by addition of these two force. No, resultant is equal by addition of these two force, if not sum of these two force. This is the resultant of the force. Right, now we have learnt about resultant of two collinear forces acting along the same direction. And in this situation, how to take the resultant force? If several forces act in the same direction, the resultant force can be taken by addition of each individual force. Right, then we will go to our next one. That is, when two collinear forces act along the same direction. The resultant of the two forces is equal to the sum of the individual force. It means last time also I have explained it. Again I will explain. Now think about there is a object like that. Right, two collinear forces act on this object like that. F1 and F2. Now think about this is the two collinear forces act on this object. Right, now think about if the resultant, if not single force that should be supplied instead of these two force is F. It means resultant force. This resultant force can be taken addition of each individual force. Is mean resultant force is equal F1 plus F2. Right, this is the way of finding the resultant force when two collinear forces act on the same direction. Right, now we have learnt about how to take the resultant force when two collinear forces act on the same direction. Right, then we will go to our next topic. Resultant of two collinear forces acting along the opposite direction. Right, now look at this diagram. These peoples provided force to this direction. Right, these people provide force to this one. Now think about these people provide F1 force. These people provide F2 force. Right, then we have to calculate the resultant force among them. Right, how to find the resultant force? Right, in this situation it means when two collinear forces act along the opposite direction, how to take the resultant forces? Right, if F1 is equal F2, it is not move into the either side. But if F1 is greater than the F2, these peoples, if not all the rod, move into this side. F2 is greater than this prop is move into this side. Right, in this situation it means when two collinear forces acting along the opposite direction. If not like that situation, now think about this one. There is an object like that. There is an object like that, right? On this side, exert a F1 force. F1 force. Here exerted F2 force. Right. Then think about F1 is greater than, if F1 is greater than F2. If F1 is greater than F2, this object is more to this side. This object is more to this side. In the resultant force, now think about if the resultant force is F, how to take the resultant force? Resultant force can be taken by substituting F2 from F1. So F1 minus F2. F2 minus F1 minus F2. This is the way of finding the resultant force. Finding the resultant force. Right now we have learned about how to calculate the resultant force of two objects when force acting in the opposite direction. Right. Then think about this one. When two collinear forces are exerted on an object in opposite direction, the resultant is given by the differences. The resultant is given by the differences with a direction in the direction of the large force. Direction of the large force. Now think about this one. Again, I will explain it like that. Now think about there is an object like that. There is an object like that. Now think about there is a 30 Newton here. 30 Newton force is exerted on this side. 30 Newton force is exerted on this side. And also 25 Newton. 25 Newton exerted on this side. Right now simply we can identify this object is move onto this side, no? Move into this side. You see this by the resultant force. Now think about resultant force F. How to calculate the resultant force? Resultant force should be calculated by 30 Newton minus 30 Newton minus 25 Newton. 25 Newton. So right, 30 minus 25 Newton means 5 Newtons. 5 Newtons. So resultant force in this situation is 5 Newton. If not, the direction of the object is direction of the large force. The direction of the object is direction of the large force, right? Then we will go to our next point. Right? Right. Then we will go to our next topic. What is the magnitude and the direction of the resultant of a force of 5 Newton pulling an object placed on a table in a certain direction and another force of 2 Newton pull in the opposite direction? Right now I have questions. Now think about there is a object like that. There is a object like that. Now we are going to solve some questions. Right. 5 Newton force is pulling force. Right. Exerted on this side, 5 Newton force. 5 Newton force. And also in a certain direction. And another force of 2 Newton pulling in the opposite direction. Right. Another force exerted on this object into the opposite direction. 2 Newton. Right now we can identify this object is more towards the 5 Newton force. No. If not, the move of the motion of the object is this direction. If not, resultant force can be taken as by substituting 2 Newton from the 5 Newton. So 5 Newton minus 2 Newtons. 5 Newtons minus 2 Newtons is the way of finding the resultant force. 5 minus 2 means 3 Newton. So answer for this question is 3 Newton. Right, then we will go to our next point, if not next question. Right, the force applied by the two children in order to push a box resting on a horizontal plane is shown in the figure. Here exerted the 15 Newton, 11 Newton. Find in the resultant force of this situation. How to find the resultant force? Now we know that how to find the resultant force, no? Resultant force is equal 15 Newton minus 11 Newton. 15 Newton minus 11 Newton. Right, now we know 15 minus 11 is 4 Newton. So resultant force is 4 Newton. Right, then we will go to our next question. Next one. A force of 10 Newton is applied towards the west. 10 Newton is applied on the west. Direction is this side. On the object placed on the table. If the object is drawn towards the west with a force of magnitude 5 Newton, what is the magnitude of the x? Right, now think about a force of 10 Newton is applied towards the west direction. West direction. Right, on the object placed on the table. If the object is drawn towards the west, object is towards the west, if it means resultant force, this resultant force is 5 Newton. Now we have supplied the resultant force. Now we have to find the x. Right, firstly we have to write the equation of the resultant force. Resultant force is equal, here the, if this object move this side, it means the large force is 10 Newton. So resultant force can be taken by 10 Newton minus x. 10 Newton minus x. 10 Newton minus x. Right, resultant force we have supplied. The resultant force 5 Newton. The resultant force 5 Newton. Resultant force is 5 Newton is equal 10 Newton minus x. Then what will happen? Then this one can be changed. When minus x came into this side, it becomes into the positive x, plus x. And plus x come into this side, it becomes into the minus 5x. 5 Newton minus 5 Newton. Minus 5 Newton. Then what will happen? Then can be calculate the value of the x like that. 10 minus 5 is 5 Newton. 10 minus 5 is 5 Newton. For answer this question is 5 Newton. Right, now we have got the answer for these questions also. Right, then we will go to our next one. Right, now we have learnt about resultant of the collinear forces. Under the resultant of the collinear forces, we have learnt about resultant of the two collinear forces act on the same direction, and then we have learnt about resultant of the two collinear forces act on the opposite direction. Right, now we are going to learn about the resultant of two parallel forces. Resultant of two parallel forces. Right, now think about first diagram. One person trying to push a motor car. Right, here the resultant force equal to the force exerted by this person. Right, now think about, now when we consider about this diagram, one person exerted a 200 Newton, another person exerted a 150 Newton. Right, like that situation. Right, these two persons supplied parallel forces on this situation. What will happen? How to calculate the resultant force like that situation? Right, then we will go to how to calculate the resultant of two parallel forces. Parallel forces. Right, in order to find the resultant of two parallel forces acting along the same direction, the two forces must be added. The two forces must be added. Right, now think about, there is an object like that. There is an object like that. Right, one force exerted like that, F1, right? And also parallel forces onto the F force exerted like that, F2. Then the single forces exerted for these two forces is resultant force. Resultant force exerted on this side. Here the resultant force, right? In that situation, how to calculate the resultant force? In this situation also, resultant force is calculated by addition these two forces, F1 plus F2, F1 plus F2. In this situation also, resultant force is calculated like that way. Right now we have learnt about how to calculate the resultant force when parallel two forces exerted on the same direction. Right, then we will go to our next point. Right, now think about, there are two forces exerted on the there are two forces exerted on this object, 8 Newton and 16 Newton. Right, in this situation, resultant force can be taken as addition of the 8 Newton plus 16 Newton, right? This one can be calculated by 8 plus 6 is 24, 2 is remaining, 8 plus 6 is 14, 1 is remaining, 1 plus 1 is 24. Answer for this question is, if not, resultant force is 24 Newton. Right, then we will go to our next one. When a trolley placed on a table is pulled by two strings attached to it, keeping the two strings parallel to each other, the resultant force is 20 Newton. Resultant force has given us, right? The force exerted on the string is 12 Newton. Find in the force exerted by the string B. String A provided 12 Newton, B provided X Newton, but resultant is 20. Right, it is the simple question, no? Right, then we will go to get the answer for this question. Resultant force is equal 12 Newton plus X. 12 Newton plus X. Right, the resultant is 20 Newton. It can be substituted into equation like that. 20 Newton is equal 12 Newton plus X. Then this one can be simplified by dividing like that. For this, both sides should be divided by the subtract by the 12 Newton. No, after that this one can be written as X is equal 20 Newton minus 12 Newton. Right, then X is equal 20 minus 12 means 8 Newtons. So the force exerted by the B is 8 Newton. Right, then we will go to our next one. Right, next one is resultant of two inclined forces. Now we have learnt about resultant of two collinear forces, and then we have learnt about resultant of two parallel forces. Now we are going to learn about the resultant of two inclined forces. Right, now think about this object. Right, on this object there is a P force like that, there is a Q force like that. It is not a coplanar or collinear, and also it is not a parallel. Those forces are known as inclined forces. Right, and also you will be you haven't calculated how to calculate the resultant force like that situation, but you can identify the direction of the resultant force when inclined forces are acted on the object. When like that inclined forces are acted on this object, the resultant forces act the resultant forces act between the two forces. Resultant force, if not direction of the resultant force, act between the two forces. Between the two forces. This is the direction of the resultant forces. This is the direction. It is not a center between the P and Q, but resultant force act between the any direction between the P and Q. Any direction in the P and Q. You haven't how to calculate the resultant force like that situation. Right now we have learned about the resultant of two collinear forces, resultant of two parallel forces, and resultant of two inclined forces. Right, then we will go to exercise of this lesson. Right now we are going to learn about the exercise in this lesson. Right, firstly we will go to question number 1. Right, question number 1, there is an object like that 10 Newton, 6 Newton is exerted on this object. No, if an object is pulled by two forces 10 Newton and 6 Newton along the same direction, what is the resultant force? What is the resultant force? Right, then we will go to get the answer for the question number 1. Right, resultant force means F can be taken by addition of the 10 Newton plus 6 Newton. So how to take the resultant force? 10 plus 6 is 16. No, 10 plus 6 is 16. So the resultant force for the, if not answer for the question number 1 is, answer for the question number 1 is 16 Newton. Right, then we will go to question number 2. Now there is a like that two forces exerted on the opposite direction. Here the 6 Newton, 10 Newton. If the two forces are applied along the two opposite direction, what would be the resultant? Right, in that situation, if the two forces act along the opposite direction, resultant force is can be taken as the differences between the two forces. Should be one force should be subtract from the another one. It means the direction in that situation is the towards the large force. Should therefore 10 Newton minus 6 Newton is used to calculate the resultant force. Now we know 10 minus 6 is 4 Newton. Therefore resultant force is 4 Newton. This 4 Newton resultant force act on the towards the large force direction, like that direction. Right now we have got the answer for the question number 1. Then we will go to get the answer for the question number 2. Question number 2 is, what is the resultant of the two parallel forces shown below? Right, 6 Newton and 4 Newton, two forces exerted on this object parallelly in the same direction. In the question number 1 asks from us what is the resultant. Right, in that situation resultant can be taken like that. If the resultant force is F, resultant force is taken as the addition of the two forces, because these two parallel forces are act on the same direction. 4 Newton plus 6 Newton, 4 plus 6 is 10 Newton. So answer for the question number 1 is 10 Newton. Answer for the question number 1 is 10 Newton. This is the answer for the question number 1. Right, then we will go to get the answer for the question number 2. Question number 2. Question number 2a. Question number 2a. Question number 2a is, what is the force that can be applied in the opposite direction so as to mark the resultant 0? Right, if we have to, right now we have found the resultant of these two forces. No, the resultant of these two forces is 10 Newton. 10 Newton. Right, therefore there is a resultant of 10 Newton here. Right, if we want to stop this object, if not resultant, we have to become a 0. For this we have to supply the 10 Newton force for the opposite direction. 10 Newton for the opposite direction. Right, in this question asked from us what is the force that can be applied in the opposite direction so as to mark the resultant 0. The mark the resultant 0, we have to apply the 10 Newton opposite direction. Right now we have learnt about, we have got the answer for the question number A. Right, illustrate it using figure. Right, we have illustrate it in the like that diagram. Right, then we will go to our next question. Right, next one is question number 3. One bull out of the pair of bull tied to a fluff for fluffing a paddy field. exert a force of 100 Newton while the other bull exert a force 80 Newton. What is the resultant? It means these two forces are act on the same direction, no? Same direction. One full act 100 Newton. 100 Newton. Another bull act 80 Newton. Right, then how to calculate the resultant force? Resultant force can be calculated by addition of these two forces. It means 100 Newton plus 100 Newton plus 80 Newton. So how to calculate the answer? 100 plus 80 is 180. 180 Newton. 180 Newton is the answer for this question. Right, then we will go to our next one, question number 4. Question number 4 is, when an object is held by a Newton balance, held by a Newton balance, right, there is a Newton balance like that. On this Newton balance, one object is held like that. Its reading was 80 Newton. Right, and then if another object of mass 500 gram was attached to the Newton balance, alright, another object attached, the mass of this object is 500 gram. 500 gram, like that, to the Newton balance. What would be the resultant force in Newton? Right, it means this 80 Newton force exerted due to the weight of the object. It means mass of this object is 8 kilogram. This one is 5 gram, no? Right, firstly we have to calculate the weight of the object. To find the weight of this object, we can use W is equal mg. Right, m means mass should be substituted into the kilogram. 500 grams mean 0.5 kilogram. 0.5 kilograms. Right, g is the gravitation. The value of the gravitation is 10 meter per square second. So 0.5 times 10 means 5 Newton. Right, therefore weight of this object is 5 Newton. 5 Newton. Weight of this object is 80 Newton. Right, these two forces act on the same direction, no? Same direction. So we have to calculate the resultant force by addition of them. So resultant force, if the resultant force F, it can be calculated by 80 Newton plus 5 Newton. 80 Newton plus 5 Newton. So resultant force is 85 Newton. Right, now we have got the answer for the question number 4 also. Right, question number 5. Then we are going to learn about how to take the answer for the question number 5. Right, firstly read the question number 5. Question number 5 is, if a trolley is being pulled by two forces, one force with a magnitude of 20 Newton along the east, and another with a magnitude of 15 Newton along the west. In which direction would it move? What is the resultant? Right, firstly we will mention the direction like that. This is the north, south, east, west. Right, now there is an object like that. Right, firstly 20 Newton act along the east. 20 Newton 20 Newton force act along the east direction, and also 15 Newton act along the west. This is the west, this is the east, this is the east, right? In this question, firstly ask from us which direction would it move. Right now we know the large force exerted on the east direction. Therefore the resultant of this, if not direction of the resultant of this situation is, if not act along the east direction, therefore this object move along to east direction. East direction, right? Then we have to calculate the resultant force. Now we know how to find the resultant force. No, if resultant force is F, resultant force is calculated by large force subtract small force, 20 minus 15 Newton. It means 20 minus 15 is 5 Newton. The direction is east direction. Resultant direction of the resultant is east direction. Right now we have got the answer for all the questions mentioned in this lesson, right? Okay, in our next video is the unit 10 chemical bonds, right? Have a nice day.